All right, there we go. Let's do a quick review. Let's see, last lesson. Yep, we learned a few data types. By short, int, long, they are all integers. Float, double, they are floats. Boolean, true or false, and the char, that's for the single character. And then we look at the multiple parameters in Java methods. So you can pass as many as you want parameters to a function or method, we'll call it. Well, as many, you probably don't want to pass too many. I think there must be a limit. Normally, you don't hit that limit. And let's see. Oh, that method is a return type, return value. So you can call a method and then pass some parameters, and then you can get a value back. But you do need the use the return. This is a keyword. Use a return and give it a type. What data type you want to return, and then we'll call it. So you can capture the value or print out the whole function call, or save the result back to a local variable and then print out. So two ways. Either way, that works. Quiz questions. What are the integer number types? Yeah, we know that, right? Why don't we just show the answers here? What are the floating point numbers? Correct the statement, float number D. So that D, that's for double, not for float. That's why you want to put an F instead of D, because you want float. Correct this statement. Oh, you want to use the single quote, single quote, not a double quote. Double quote, that's for string. Correct this statement, byte B equal to 1 to 8. Why that's wrong? You want to use either short B 1 to 8 or int B 1 to 8, not a byte, because remember, for byte, the maximum value is 1 to 7. The negative 1 to 8 to 1 to 7. So not positive 1 to 8. Write a method that returns the result of the first int minus a second. Okay, yeah, let's just do a function, do the minus. So you have two numbers, minus y from x, or x minus y, and return a int value. So, okay, let's see. Method overloading. Oh, that's crowded. Oh, wait a minute. Oh, that's not right. So where's that method overloading? So I think there's something wrong there. Let me display. Let me correct it. I have a local copy, I think. No. Now just open the file. Let me open the file. That's my book. Yeah, that's my local copy. Method overloading. Yeah, no, that doesn't work. So must be here. Method overloading, method overloading. Okay. And I'll fix it. So this is page. Why it's not showing it? Come on. Method overloading. Yeah. Oh. Yeah. We don't need that. And method overloading. Oh, it's right there, right? Let me reload the page. Yeah. In your version, you are using you're accessing the upload version. This is local. I will upload this version later. But for now, just look at my screen. So yeah, let's start with Java operators. So in Java or in many programming language, there are different types of operators. So this arithmetic, that's for math, assignment operators, comparison, compare two values, and logical, that's like a if, else, then, those kind of operators. And by the way, we probably don't need that, so we can ignore that as well. Let's look at the arithmetic operators here. Here's a table, list all the math operators. So basically it's a math, right? So plus, minus, multiply, divided by. The modulus is return the division remainder. And plus, that's interesting. It's not addition. It's like you increase the value of a variable by 1. So that probably apply to integers, right? Increase by 1. Minus 2, that's not a single. So minus, 2 minus. That's called a decrement. You decrease the value of a variable by 1. So that's decrease. I think this thing can go either before the variable or after. There's a subtle difference. We will learn that later. But for now, either in front or back, basically you change the variable by 1, either add 1 or minus 1. Let's try those with some examples here, okay? Why don't we type that here? Let me open this file. Let me clean up. Yeah. Oh, well, let's not clean up too much. We want to keep this the main method. Remember that we need to keep one function at least, the main here. Yeah. Let's see. We have 2 integers. One is x. Make it bigger. Right. Make it another variable. Make it smaller. Fine. Smaller. Okay. We got 2 variables, and do some math. Right. We want to print out. Yeah, let's print out a new variable. And this new variable, we call it int z equal to, let's say my plus, right? X plus y. So then, that should work. And let me drag a command window here. Second. Okay, it's here. make that a smaller. And I send a knee. And yeah, this is the location. And type of that location. I think it's under where? What? No kidding. Didn't work. So, yeah, now files. Go. Clear. You should have a main. Remember the Java C to compile. Oops. Java. Oh well, doesn't matter. We have to save the file, compile again, and let's run it. So remember input x 100, y 30 plus that should be 130, and see if that's the case. No, it's 130, right? If you want to make a more readable, then you can do this. Set x plus, oops, plus y equal to plus z, and let's save that, compile. Yeah. So what we're doing here is, okay, this is a variable x plus this plus is not the math plus. This plus is to add like a two string, and here is a string. We want that space plus space. So that's a 3-character string. We use double quote and append that to x, and then plus a string that's the y value, the value of variable y, and add the space equal space here, the string, another string, and add the string z, or the value of z, that's the result of this addition. So that's why we get this. That looks better, right? And then for minus, of course, just change that to minus. And here, we want to sort this out. So then this is not plus anymore, it's a minus, right? Save the file, compile, and run. So it's 100 minus 30 equal to 70, right? So it's pretty interesting here. Then next one we do a multiply, the multiplication. That means do that. And of course here, is that. Looks good. Compile. Run. Yeah, let's result it. And of course, division. Let's see if we can just do that. Save it. File. Run the program. There. Well, yeah, 100 divided by 30 is, it's not exact 3, but we only keep integer. Oh, because we define the z as an integer. You probably want to, that should be 3.333 forever. So let's try that. Maybe we can use a float. Yeah, see what happens. Different result. Run it. Oh, that's still 3. That's still 3. Let's do something else then. Flow. Let's try that trick. Say we want the result to be float. Let's see if that helps. Pile. And no, still not that. So let's do something further. Okay, convert x to float and convert y to float. Do the division and then save the results. Let's see if that helps. Okay. Ah, that's much better. Look at that. Look at that. Now it's a float. We have all the decimals. We do need to convert the integer x to a float variable and convert the y, also an integer, to float, and then do the division, and then save to the value, a new variable. And then we do have that. But in case you want, more decimal points, then you can change it to double. Remember, double is much bigger. I think it's 4 times bigger. Double. There's a name on this. This is called a type conversion. The type conversion is convert type int to new type double to have better precision. And so this type conversion, and yeah, otherwise the result is going to be just the integer, only 3. If we change from float to double, we should have more decimal points. I think we have up to 15 decimal points for double, right? Let's see. Save it. Compile the file. Okay, run it. Well, not 50, but it gave up, and it's 5. I believe it's 5. But I thought it's just 3 forever, right? Yeah. It's okay. It's just like after 3, 5 is not that accurate anymore, but we don't care. I just want to make sure, yeah, I'm not muted. Great. Okay. Division, the modulus. Yeah, the modulus. That's the remainder of division. Not, this is the division result, and we are looking for remainder. Let's see. Remainder, that means, oh, since we are doing, let's keep the double for now, see what happens. May throw error, but I don't know. Let's do that. Save it. Every time you change the program, you have to compile before you run it. Step. Remainder is 10. Yeah, probably, right? Let's see. So that's 3, that's 90. So 100 minus 90. Yeah, 3. Yeah, 100 minus 90 is 10. Yeah. So they converted type, doesn't really impact that much. And so if the remainder number, yeah, we don't need that much precision there. So you can do that. If the result should be the same, with 10 or 10.0. On it. Yeah, so it's the same. The last one, no, it's not the last one. Oh, increment, decrement, yes. Let's try that. Let's see. let's do, okay, let's increase x by 1 and then print out x plus x. So it should be 100, but after the x plus plus, then we should get 101. If that's the case, compile, run the program. Yeah, it's 101. Any difference between and of course not. That's called a, this is called a pre-increment. The first one is called post-increment. And let's see the double, the subtle difference, okay? Let's see. Let's save it. And clear my screen. Compile. A little faster compared with running the program on the web, right? Yeah, that's 1 and 1, no difference. So you, the double plus sign in front or after, there's no difference because they're on different line. So either that or that, you know, it take effect on that line, and then the next line we get a final result. However, if we print the x plus, okay, and let's see what happens. You think it's going to be 101 or 100? Make a bet. 100 or 101. See what happens. Still 100. Still 100, right? What happened is this called a post increment. That means this increase by 1 take effect after this line. That means in this line, if you want to print x plus plus, actually you are printing the value of x, not x plus plus. That's why you still get 100. It looks like the plus plus doesn't impact this line. But if you print again on the next line, now print this, don't add plus plus, or doesn't matter. If you print that, you will see that. Look, so on this line is printing out 100, and this line is printing out actually 100 plus 1. So that's why I got 101 from this line, and from that line you still get 100. That's the original value. Okay. Yeah, let's do that. Add another line, so you see how the value change. So basically 100, 100, and 101. So this is like you know, this plus plus, the effect of plus plus is delayed to next line. Okay, delayed to next line. But if you do this, it's also add 1 to x, but this one will take effect on this line. Basically, okay, add 1 first and then print. In the previous cases, print and then add 1. So that's a subtle difference. And let's from that. No. See, 100, add 1, print, and then of course next line is still 101. So 100, 1, 1, 1, 1. In the previous case is 100, 100, 1, 1. That's like subtle difference. And similarly, the minor mass, I think that's the same effect. Let's do that. -1, -1, okay? make a guess in your mind. So make a guess. So 100, 100 or 99, and then 99. Make a guess and see if you're correct. Yeah, see 100, 99, 99. And then remember that post instead of pre. No difference now. Compile again. Yep, in this case is 100, still 100, and then 99. All right. You may ask, oh, why do we need that? Why do we need the differentiate between the pre and the post? And you know, in programming, you will, if you do the Java programming, you know, in future you will, or in real application, you will see this actually does make a difference. That means it's useful. This subtle difference actually is useful. Okay. Let's see. We got that. Yeah. We look at that pretty much all these operators. Let me see the time here. Yep. Good. Then let's move on to, we have many other operators. We will look at the assignment comparison next lesson. But for today, I think these math operators are good enough for today. Let's move on to the Java method again. Method overloading. What does that mean? Let's do a real example. Let's see here example. Let me just copy that thing. Yeah. Copy that. What do we have here is, let's say we want to add two numbers, right? We have two integers. We want to add them and save the result to number 1. And then we have two doubles. We have two double values. And we call a method called a plus method double. So basically add two doubles. That's another method. And save that to a different variable to store the result, and then we print them out. And of course, since we have a method to add an int, we have a method to add a double, then we have, you know, we have to define two methods, right? This is double, this is int. So we have two methods. In this case, there's no overloading. I mean, it's different, you know, different parameter, different name, even different return value. Yeah, they are all different. They don't impact each other. They have no relation between them. So this is no overloading. This, if we compile the program and run it, of course it runs, you get a result. Oh, did I save? No. That's why. Yeah, the first one you add 8 and 5, that's 13. Yeah, of course. You add a 4.3 and a 626. Well, since we save that to a double, the double to double, we got it should be like a 10.56, right? 10.56. But you can see that the computer is, you know, is, how do you say that? It's depending on the when you run it, you may get a 5.6, or you may get a 5.999, or you may get a 5.6.0001. So that's like a pretty random. The run program game. It may be a different result. turn out, yeah, it's always that. That's the nature of double, I guess. It should be just 5, 6, right? So two methods to do the similar things, similar because we just want to add two numbers. Then we want to ask, can we just use a when method since we are doing just, let's say if we want to add two long numbers to short numbers, then we have to create so many functions. Then just to save coding or save the lines, then the Java allows the method overloading, means you can use this one method to do multiple things. Similar thing, but a little bit different. Like you added to different parameter types, integer, double, float, short, long, whatever, but all use the same method. Can we do that? I believe we can. Let's see if we can, how do we do that? Yeah, you don't have to call different. You just say, okay, plus method, or how about we just like addition, right? Or addition. But you still have to define them differently. You define the same method name, but different parameter types, or even different return value. And in this case, like that, it's just like a same method name, but different parameters. In this case, called a method overloading, right? Overloading means you have more than one meaning. You have multiple meaning, or multiple functions, or multiple purpose, right? So that's, and then when you call, you don't have to call different method. You just call one method. It's all called addition, right? Copy that. Now the code is, a lot easier, cleaner. You say, oh yeah, addition, fine, this is addition. Of course, you pass different parameters to it. This is called overloading. Let me save. Say compile it. Did I compile? Wait. Okay. Yeah, that still works. See, even different. Then of course you can add more, make it a more, make it a overloading more. So still addition, but we want to add two floats. Float number. Float. Right. And do this. And now, of course, we added a float. 3. Yeah, that's still float. And we can even add the same numbers. Right, same numbers. They convert to float automatically. Because we take a float, it will, even if we pass it's either a float or long or double, they convert to float and add them and return float back. And of course, we want to print the result out. Okay. Float. 3. With 3 methods of the same name, but different parameters. We call it sometimes called a different signature, method signature. There's different signature. Or you can just Yeah, maybe that's too much. Just call it different parameters, different parameter types. Yeah. No, let me save them. Oops. Got error. Losing conversion from double to float. Fine. So yeah, I think yeah, when we learn the type with a decimal, default is double. So basically say, hey, you pass double and yeah. We are converting double to float. Can we convert to double to float? Yes, but we have to specifically tell it to do it. So we either, that's flow. We either do this, I think. Just convert. Yeah, since for 3 default is double, we only care about the flow part. So convert it before you pass it or call the function. That should avoid this error message. Let me see. Ah, that's better. And let's run it. See the precision. When it's a double, it keep more decimal digits. For float, it just keep the only 2. And actually, this is more accurate than the double. That's interesting. That's one way to do it. Another way, I think, is instead of the conversion, if we know it's float, we just have F. Don't bother do the conversion. I'm giving you, I'm passing a flow number. Right? And this should also work. Save it. File. Yep, so it's the same result. So maybe this is cleaner instead of using the float to convert. And you make it even better. You can just say, okay, give me a double. I'm calling the second function here, double. So I'm double, save double. And for this one, I'm giving you FF, the float, and give me a float number. So that should work. Let me save it. Compile and run it. Yeah, see the no complaint. So yeah, you can see that 2 different ways to do it. Either use a DDFF to mark the number as double or float, or in front type the float, parentheses float. That's called a type conversion. Okay. Okay, almost that time. What else we want to look at? Yeah, this is called a method overloading. Oh, another interesting thing is, can we pass different parameter. And can we use the same name, different parameter, but return the same value type as a float? So I'll give you 2 double, give me a float. I give you 2 float, give me a float. Will that break anything? Oh, it marks something funny already. Type of mismatch cannot come from double to float. Oh, that cannot means I cannot do it by myself. You have to tell me you want to do it. I think that's what it's talking about. In this case, we want to group the mass together and convert to float return. See if we can do that. Don't have syntax error. That's a good sign. Let's compile. and wrong. Wow, okay. So see how much overloading we can do to function, between these two, we can have same name and even same return type, but of course, different parameters, the input parameters, okay? So this, not just the same name, but also the same return type. So that overloading is still allowed. Then the next question is, oh, you know what? Can I make one more thing interesting? How about at least instead of a totally different type from double to float, can I do the half, like a double, just half difference? Well, we cannot do the all, double, then there's no need, right? The same function. If I change that also to double, we know that it's not necessary because now you got an error. Hey, you got what are you talking about? You got two functions exactly the same. What's the point? Of course, that's syntax error. If I put here is a duplicate method, right? Now you have a duplicate method in type. You have the input type, same, output type, same. So it's, of course, that's error. Now, what if we just, have, same type, name, same input type, parameter for parameter 1, and different type for 2. Is that allowed? Oh, here is the error. Type of cannot convert from double to float. Oh, fine. Yeah, let's also do the conversion. Oh, there you go. No syntax error. Let's see. Save it. Compile. My wrong command here. Oh, wow, that allows also. So, wow. So we can see that you can overload the Java method so much that as long as one input parameter is different, then you're fine. You can, treat that as a different method. Yeah, what if we use double here? We can use double here, but different here, double here. That okay? Duplicate method. Oh, so yeah. So the input parameter, you cannot have the exact same input parameter type. Then it's treated as duplicate. So at least one of them should be different, right? One of them should be different. Okay, you can add an int, I think. Yeah. As long as one of them different, then it's a new method. It's treated as a new method. Okay. All right, I think. Oh, okay, 48. I think we should stop here. We stop sharing. Start recording.